Hello everyone, we're Group 21. Thank you very much for watching this demo for our final project, an intelligent water refilling system. This is the overview of our system. You may have figured out several subsystems, cause some of them are quite obvious. We shall just start from the largest piece, which is the scaling subsystem. This unit consists of a wooden board with the weighting components mounted onto the bottom of the board. Whenever an object is placed on this scale, a small electrical signal will be produced and amplified by the HX711 board along its side. Now let's move to the water tank part. Here is the water tap driven by a servo. We have also attached an ultrasonic sensor unit at its bottom side. Such unit is able to read the distance between itself and the water level. It feeds the data to Raspberry Pi, our microcontroller. We have modularized the whole system by integrating subsystems onto different breadboards separately. This breadboard is a control system for both the servo and the ultrasonic sensor. Here is the temperature module controlling the thermometer and the heating pad. Same as the scaling part, it feeds data back to the microcontroller. The rod in the water tank is a thermometer. When the temperature is lower than some customized threshold, the heating system will be triggered. The LED will light up and the pad will start heating. This LED panel displays the current water temperature in both Celsius and Fahrenheit. The current date is shown as an add-up function as well. It also shows you how much amount of water you are suggested to drink at that particular day.
Now let's move on to our first function of our system, refilling water. When we put the cup on the scale, the control chip will receive a true message and then start the water refilling module. When the distance between water level and the ultrasonic sensor is smaller than a specific distance, it will tell the Raspberry Pi, "Stop adding water, it's full." Now let's go to the second function of our system, temperature monitoring and maintenance. The temperature is 23 degrees C now, which is too low, so the LED is on and the heating film is currently working. It is 43 degrees C now, hot enough, heating stopped.
Now we are going to introduce our final function of our system, data visualization. This is the server side and its database on the cloud to record the data for temperature and water drinking amount, and the other are its corresponding upload time. Then we take a look at the client side. People can request a monthly and daily graph report for the temperature and water drinking amount from the server database. The first graph represents the average water temperature per day in the specific month. Then we take a look at the daily graph water temperature in each specific moment in the December 2nd. Then we enter the command in the terminal to see the total amount of water drinking per day in a specific month. And finally, we output the amount of water drinking at each specific moment in the date of December 14th. We believe that the data we record can not only be useful for visualization, but also for machine learning, which can be used in the future development.